Hello, everyone. Thank you for joining us in this webinar. This is one of the webinars of the Women in Africa webinar series. This is our feed webinar, and we are delighted to have Pamela as our speaker. She's a great woman, and we have had great women on this platform. We hope her experience will teach all of us, and we shall gain insights on what we can do to improve in our careers and in our personal life. Thank you. I will give the floor to Barry.
Okay, I'll just go right in because we're already behind schedule. So I don't know if everyone can hear me.
Yes, we can.
Okay, thank you very much. So very quickly, I'm just going to introduce our guests. Sorry once again for delaying the time. Today we have a very special guest with us, and we are so glad, we're actually delighted that she was able to join us on a very short notice. Dr. Pamela Ochungo is a dedicated geospatial scientist and researcher with nearly 2 decades of experience in applying GIS and remote sensing technologies to address real-world challenges. Currently, she's a lecturer in the Department of Survey and Spatial Science at the Technical University of Kenya. She holds a PhD in conservation ecology from Stellenbosch University, an MSc in GIS, and a BSc in surveying. A diverse career includes over 15 years at renowned research institutions such as the International Livestock Research Institute, ILRI, and International Center of Insect Physiology and Ecology, ICIPE, where she led and collaborated on multidisciplinary projects focused on environmental sustainability, food safety, and disease mapping. Dr. Ochungo's research integrates spatial data and socioeconomic analysis to explore complex patterns in human and ecological systems. She is a published author in international journals, and she's very passionate about mentoring and inspiring the next generation of social scientists to harness the power of geospatial technologies. Please let's welcome Dr. Pamela Ochungo.
Thank you so much, Ari and Mary, for that introduction. I'm glad to be here. And I just want to thank each and every one of you for making time out to come and listen to my experiences as a geospatial scientist within the social science realm. So because of time, I'm not going to take too much time talking about the intro, but I'm going to be walking you through briefly how geospatial technologies are being used and how I have also used them in social science research. And I'll be drawing mainly from personal experience, but with a little bit of theoretical introduction. So there is a growing recognition in the social sciences about something that we are calling the spatial turn, okay? And this means that more and more researchers are realizing that where things happen, not just what or why, but where things happen is just as important as what or why things are happening. And so this has led to the rise of what some are calling spatial social science. And this is a fusion of geography, technology, and the traditional social sciences like sociology, economics, anthropology, and as well as development studies. And so GIS is turning out to be a really critical area, a really critical field in these areas of spatial social sciences because of the importance of where things are happening. So quickly, let's just go over what, just a brief definition of what are geospatial technologies. So geospatial technologies are a set of digital tools that help us to collect, visualize, and analyze data that has a location component. So the difference between statistical data, normal statistical data, and geospatial data or georeference data is that you do have columns, two specific columns of latitude and longitude, or X and Y, that tell you where these features are, or phenomena are, or events are occurring. And so there are a set of digital tools that allow us to collect, analyze, and visualize data that has this location component. And they include, for example, the GPSs, satellite imagery, like you can see that image there is of a satellite, GIS software, and even tools like Google Earth, which we all now have on our phones. We do have Google Maps, and you can also turn on the satellite imagery background on your Google Maps, and you can be able to see the satellite portion of it. So in social sciences, these tools allow us to ask some of the most powerful research questions, that is where. For example, where is poverty concentrated? Social sciences are, concerned with issues such as poverty, such as, socioeconomic perspectives, and so on. So they allow us to ask, for instance, where is poverty concentrated? Where are the services lacking? Where do people move, and why? So these are some of the important social questions that are asked using geospatial technologies in those fields. So now just a brief of the differences between using geospatial technologies in more of the engineering fields versus the social sciences, because some of you may be asking yourselves, so what is the difference between using this kind of technologies in the traditional engineering surveying fields versus in the social sciences? So now that we understand what geospatial technologies are, it's also important to recognize how differently they're used in these fields. For example, engineers and social scientists will both use GPS, GIS, and remote sensing, but their end goals are different. The data types that they require are different, and the precision requirements also differ significantly. For instance, if you look at this second row, talking about the typical uses of geospatial technology, in engineering, you're talking about surveying, construction design. And in this way, in engineering and social and construction design, you require precision. So precision is everything. Whereas in social sciences, you'll be talking about mapping of poverty, migration patterns, for example. And here we are talking about how human behavior and social systems relate to space, in other words, relate to location. And therefore, you do not require the kind of precision that you would be requiring in engineering. And also the data types. So in engineering, we rely mainly on metrics, physical data like elevation. For instance, I do have a surveying background. That is my bachelor's degree. And there we look at really, precision, high accuracies. You cannot, for instance, survey a person's land plot and, give room for any kind of errors. You must have centimeter or millimeter precision. Whereas when you're talking about, social sciences, you're talking about household surveys, you're talking about censuses, you're talking about narratives, and here you do not require precision or high precision. I'm not saying that they do not require accuracy, but you do not require centimeter level precision. And therefore, there's a difference in the kind of data that is collected and the intensity that is put to collecting this kind of data. And then, you're talking about centimeter level accuracies for construction, whereas in social sciences, a few meters are often enough. And therefore, you find that in social sciences, you're more concerned with patterns rather than precision. And so this last row answers it, captures it perfectly in terms of engineering asks where and how do we build, whereas social sciences is asking who is affected and how are they affected, and why. So there's a big difference in terms of the kind of data required. For instance, I'll just give an example of GPS, okay? So GPS used in engineering and surveying will most likely not be the handheld GPSs. It'll most likely be the real-time kinetic or RTK surveying equipment, whereby you do have a base station and then you have a rover that is capturing satellites and correcting them with reference to the base station, okay? And therefore coming up with centimeter level or even sub-centimeter level accuracies. Whereas when you're going for a household survey, you just have a handheld GPS, and we know that handheld GPSs usually give us about 3 meters of accuracy. These days with the GNSS, and you have all the GLONASS, you have the GPS, you have the Galileo, and therefore you're able to get 3 meters of accuracy. Previously, even 5 meters was acceptable. So it all begins with Dr. John Snow, whereby this is one of the earliest and most famous examples of spatial analysis in health in 1854. So there was an outbreak of cholera, and people thought that this outbreak came from bad air, okay? But Dr. John Snow mapped the cases and traced them. So he was using very rudimentary methods, just placing points at areas where cholera had occurred. And then just by using this sort of rudimentary methods, he traced the outbreak of cholera to a contaminated water pump. So this was a dot map that he used to illustrate the cluster of cases around the pump. So this analysis of Dr. John Snow way back in 1854 changed public health systems forever. So my own work has taken me across the country of Kenya, across the region, into the neighboring countries of Uganda, Tanzania, and even to Western Africa to carry out spatial analysis for a variety of challenges in the social sciences realm. So I've used it to plan surveys, I've used it to analyze data, I've used it to visualize patterns, and even to help communities to advocate for services which they require and which would not be obvious without the presence of geospatial data. So I'll be sharing, as I speak, I'll be sharing real life examples throughout this presentation. So what are the data types that I've normally used? So here we do have, we have human data. So I will answer these later on as we move. So we have, the main thing is human data when we're talking about social sciences. And we have settlements, we have migration, we have public services. And so the main thing is that in social sciences, we integrate human data, whereas in the non-social sciences, like for example, engineering work, surveying works, we really are not focused so much on data, but we are more focused on measurements, on precision, on levels. How can we build this road? How can we take measurements? How can we carry out topo surveys? Although these days, even for the physical data, for the engineering works, you find that they bring in anthropologists, they bring in social scientists to ensure that maybe as people are being relocated, it is being done in a way that is equitable and fair. And so in social sciences, we use data such as settlements, migration, settlements, migration, public services, and human data tells us about populations. For instance, what kind of populations are there? What is the, how are they segregated in terms of male, female, age? What ages are we talking about here? And these are the kind of segregations that come in very handy when analyzing social science data, because they'll be looking at, say, for instance, does age affect, the possibility that somebody will migrate from the rural to the urban area? Or does age affect, whether somebody is going to adopt a certain technology with regard to, say, dairy farming, and this is in the agricultural economics area, and so on. So physical data, you'll be talking about rivers, landforms, elevation, and so on and so forth, terrain. And then we also differentiate between primary data and secondary data, whereby primary data is data that we collect by ourselves in surveys, like for instance, household surveys, you have interviews, you're going to talk to people in the field, you're going to take photographs and so on. So to capture more of the social data. And then you also have secondary data, which is coming from like censuses, online databases, reports, which somebody else collected, and then you want to use it. So ideally, the most ideal situation is whereby you can combine all this data to give you a richer, more layered understanding of a community, a landscape, and so on and so forth. So now with regard to tools, I see a question they're already asking about toolboxes and things. So this is now the page that I'm going to talk about tools. So we have several options for collecting spatial data in the field. For instance, we have handheld GPSs. GPS is a global positioning satellite. So it's a receiver which receives satellites which are, located in space about 10 kilometers above Earth's surface. And so GPS is most commonly spoken about because it was the earliest system that was utilizing these satellites, positioning satellites. But ideally, GPS is an American system. We do also have the Russian system like GLONASS. We have the European Union system, which is Galileo. And then we also have the BeiDou from China. So all these nowadays are, some handsets are able to collect positioning information from all these satellites. And these are the GNSS handheld systems. And they give accuracies of up to, these days, we're talking about 3 meters. 5 meters is mainly when you're dealing with like the ODK, that is the open data kit platforms. So with a GPS, you can go to a household which you want to interview a person, and then you take the position, of course with consent first. You have to ask for consent from the household which you are interviewing, and then you have the information now from all the household information which will be additional to the GPS location. So you then have georeferenced information. You also have mobile apps which are becoming very popular, like the ODK. So ODK is an open data kit, and these are mobile data collection tools. So ODK is popular, but also Kobo Collect is popular, and I have experience with both, and they're almost the same kind of platforms. So what happens is these platforms are brought about to replace paper forms. So instead of walking about with boxes of paper, you have, a whole form that has been created online, and then it has been deployed onto a mobile phone or a tablet, and then you're able now to answer the questions on this phone. And the beauty of this is you do not need the internet to be able to collect the data while you're out in the field. So this is also a very useful platform that I have used severally in different countries, in Madagascar as well, and I've also trained the people how to use them just using your ordinary Android phone. For now, the Apple is still not onboarding with these mobile apps like the ODK. Then we also have the digital globes like Google Earth. So Google Earth Pro is one of the digital globes, and it is not just an explorer. It's not just for visualization, but it also assists with collecting high resolution data. For example, if you want to collect data for carrying out, a remote sensing analysis in the social sciences, you can just zoom in to these digital globes like Google Earth Pro and trace a polygon or a point, which then you can integrate with your other data sets. Because once you trace this and you save it, it is a georeferenced point, and it saves itself as a keyhole markup language file. That's a KML file. So it is absolutely a very useful platform for not just visualization, but also collection of data. And then the beauty with it is it also provides really high resolution images, 1 meter resolution, which you'd not be able to get with our typical Landsat or Sentinel kind of data. And then you have drones, which are now becoming extremely popular. especially when you have smaller areas to cover with high resolution. You can fit in whatever kind of sensor that you require, whether it's a multispectral sensor or a hyperspectral sensor or whatever it is that you require to map out, for instance, households and the kind of land uses around them. And then, these can be post-processed after collection. Okay, so these enable us to get custom, up-to-date aerial imagery that are as needed. So the tool that you choose should be based on your required level of detail. For instance, if you require high detail, you can select to use a drone. You can select to use Google Earth Pro high resolution images, although they have a certain lag, so you may not get it very up to date. But with drones, you can get up to date. So depending on the level of detail that you require, you can choose any of these tools to help you to collect data that you require. Now, one of the important things that I have found to be useful out in the field is sampling techniques, especially when you're going to do social science research. Why? Because in social science, mainly they want to interview households, they want to carry out maybe these interviews that are involving, say, groups of people and so on. And so how do you ensure that you are sampling the right numbers? Okay, how do you ensure that you are sampling the right people and that you're not biasing your surveys? Okay, you don't want, the last thing that you want to do is to go out into the field, collect your data, and then when you come back to the office, you're told the 1 month that you spent in the field is literally a waste of time because all the data seems to be along a road. Okay, and we are human. We want to take sometimes the easy way out. And so what do? We have been given a vehicle to go to the field. This vehicle is driving along a road. And so along this road, you stop, you see a household, you drop off, you go to the household, you interview, you come back to the vehicle, you drive again, you see another household, and so on. And so when you map this data, you'll find that these houses are spread along the road. They're not spread out the way they should, but they're spread along the road. And what consequences will this have? This will have consequences of bias for households of people living along the road who have some advantages that those living far from the road do not have. And therefore, sampling is very critical. And I use a lot of random sampling, systematic, stratified, and so on, before I went out into the field, selected households before I went out in the field to ensure that what data was being collected was as unbiased as possible. Of course, you can never completely eliminate bias to zero, but you can try as much as possible to reduce the bias by carrying out sampling techniques. So for example, for a random sample, it means that every household, for example, has an equal chance of being selected to be interviewed in that survey. If you're looking at a systematic sample means that, say, for instance, at every regular interval, say every fifth person or every fifth household, you are going to carry out a survey. A stratified sample is very useful, especially if you want to compare across different groups. For example, rural versus urban groups, male versus female, and so on and so forth, okay? And then, you have stratified random, which now start combining between the stratified and the random samples, and also stratified systematic samples. So these, usually I found that I combined them. For instance, I carried out stratified random, whereas I stratified by population, such that I have a certain population and I want to carry out a random sample within that population so that I then have equal sort of numbers across the different kinds of strata, okay? So this was one of the very important exercises to carry out before going out into the field, and I would always advise that somebody does that. So as a case study, this is a project that I worked on for a number of years, and it was called the EADD project. The EADD project stands for the East African Daily Development project. And in this project, I was working with agricultural economists, gender specialists, people who are essentially carrying out social sciences. So the objective of the East African Dairy Development was to double the income of farmers in certain selected areas of the country. Actually, it was not just the country, it was Kenya and Uganda. So to double their income within a certain number of years by putting in certain measures. And these measures were, for instance, if you look closely at this first image here, there's a place called Soy, which is in North Rift, Kenya. And that blue triangle represents what we call a hub. So these hubs were to be created in order to facilitate the farmers by, putting in milk cooling plants in those hubs, putting in agrovet services and other services that a farmer requires, okay, so that they do not have to go far away to have these services, and also to enable these dairy farmers to cool their milk so that their milk does not go bad before it goes to the market. And so there was a lot of work that had to go into selecting of the farmers, selecting of the households who were to be interviewed. So in this instance, I was the lead geospatial analyst in this project. And in this instance, you can see in the first circle, this is, you can see some grid. So this grid I created of a certain dimension, so that then I would carry out random some stratified samples of the households that were to be interviewed before going out into the field. So here, these were based on, the strata was based on population, and then I came up with these households. So each grade was representing a household, and then I carried out then a random sample of those grids. And then the end product was the image on the right, or the map on the right, with numbered households, georeferenced, randomly selected numbered households, which would then be uploaded into the GPS before we went out into the field. And therefore, when we went out into the field, we used the GPS function called go to find the house. Of course, this is not an easy exercise, especially when you're out into the field and you find that this household, there's a barrier to getting it and so on and so forth. But what it ensured is a uniform or nearly uniform spread of households that were to be interviewed, and therefore to ensure that every person had an equitable chance of being selected, or every household. So this project we looked at, as I've said, there's households, there's cooling plants, there's market access. So the market access measures, I used to calculate them, by looking at type of road, in terms of the surface type. Was it bound? Was it loose? And so on. What were the kind of speeds that were possible on these roads? How did these then ensure accessibility to markets for these farmers who were keeping dairy, whose products were highly perishable, and who needed to access a ready market? Okay, so this was really one of the biggest projects that I worked on, funded by Bill and Melinda Gates, and it ensured that, we delivered evidence-based dairy development that benefited thousands of farmers at several locations in Kenya and Uganda. And then so that is just one example. I'm not going to share too many examples because of time. But then after such an exercise like this, you need to analyze this data. You have gone to the field, you have collected your reference location data like household data. So what next? Okay, so there's several kinds of GIS analysis that were possible, and remote sensing analysis. For instance, proximity analysis like buffers, remote sensing analysis to extract land use, land cover data. And then after that, we would carry out regression analysis, which are statistical analysis, which combine both spatial and non-spatial data to come up with some sort of interventions or some sort of results that allow certain interventions to be carried out. So for instance, for buffer analysis, in this case, for this, still this is the East African Dairy Development project, and these are concentric buffers around one of the hubs, and this is somewhere in central Kenya. So these concentric buffers, for instance, you're looking at how many households are living within a 500-meter buffer or radius of a milk cooling plant. So you want to know how many of them and how long would it take them to get to that milk cooling plant, and so on and so forth. And then these concentric buffers, the other red buffer is also to test. Say, for instance, if we move 1 kilometer away, how long would it take, you know, using various road types? And for instance, in those rural areas, you mostly have the dry surface road types that can become very impassable during rainy season. So how can we use GIS to recommend the best routes for these farmers to get to the milk cooling plant so that their milk does not become spoiled? You know, their milk is perishable. So this is you know, a practical, you know, buffer analysis in action, and which assisted farmers to decide how, you know, how to you know, where to take their milk and how to move to get their milk to that cooling plant so that they could preserve their livelihood. And then we also have, you know, another example being suitability, site suitability analysis. And in most of the social science work that I did, we looked at criteria such as distances, rainfall amounts, accessibility using road types, and so on. And here we also set thresholds like, you know, how far is it from the market, and so on and so forth. So, you know, this is called an overlay operation, and it's one of the most popular operations in GIS that is used a lot in engineering and surveying sciences, but also came in really handy in the social sciences. And these helped to guide you know, development planning. So for instance, this is an extract from a paper, a publication that we published called The Targeting of Dairy Interventions in Kenya, and it was a guide for development planners, researchers, and extension workers out into the field. And I was one of the authors and produced all of the maps that were used in the publication. So for instance, this is an extract from the publication looking at one of the dairy technologies that we're looking at, which is like Napier. So Napier grass is a fodder crop that is used for cattle, dairy cattle, in intensively farmed systems. And so assessing where can Napier be planted so that it can be optimized for the farmers, and also so that the Napier grass is in a place that is most suitable. So several criteria were developed, for instance, agroclimatic potential, which can be represented by, for instance, length of growing period, or, any of, there are several agroclimatic potential indicators that can be used, but in this case, we use the length of growing period. And then access to markets, again, was the same means that I used to calculate market access to different, sizes of markets. What are the farming systems? Are they intensive? Are they extensive? And we know that in intensive farms, this is where fodder crops come in very handy, compared to extensive systems, whereby in extensive systems, mostly the cattle will graze, okay? Then we have other social data like income sources, off-farm income sources, and so on, and also bringing in the climatic conditions. So we used, regression analysis using both the spatial and the non-spatial data to come up with, where are the most suitable locations for planting Napier and other fodder. And this was also extended to, say, for instance, where are dairy cattle most likely to be adopted based on the same criteria and, slightly different criteria, and so on. And then coming up with a map such that, as what you see on the lower left, showing which are the areas most likely to be suitable for growing of Napier. So this assists with targeting of these interventions, assisting the extension agents to know where to go with their technologies, assisting the researchers to know which areas will be most suitable for these kind of technologies. And this can be found in this publication. And I will share this presentation so that, if you're interested in such, you can always access that publication. Also from the same publication, we'll be looking at risk mapping. For instance, in social sciences, you're looking at where do we have the most vulnerable populations, okay? So this, for instance, is a map showing, which farmers have high milk surplus and low market access. So this means that they're unable to access markets. And what is the result of that? Their milk is likely to go bad, and then it becomes an investment that goes down to zero. Okay, so also where do you have, high milk surplus and good market access, and these are the kind of people that are able to access markets easily, and therefore they can also be targeted for different interventions. So it's all about how do we target the right populations in social sciences using GIS data, okay? So here you have, like, for instance, where do you have what kind of dairy data do you have that can allow you to target vulnerable populations, to target poor populations with what kind of poverty indices are we able to calculate that enable better resource allocation. So this again is from the same publication that we wrote. And then now let me move to archaeology. And in archaeology, there's also projects that I'm currently working on and that I also worked on in the past. For example, we can find new sites using high resolution imagery. So for instance, this image up here, this is a Google Earth Pro image, and it allows us to see things that we would not see from the ground. We can see them from above. So high resolution satellite imagery and also inclusion of drones is helping us to discover archaeological sites without having to dig. So previously, before the use of these geospatial technologies, archaeologists would have to rely on other techniques and then go and excavate to say, for instance, find evidence that this is an archaeological site. But now with high resolution platforms like the digital globes like Google Earth Pro, we are able to access high resolution imagery up to 1 meter and find sites before going to the ground to ground truth these sites. And then we also can incorporate drones in areas whereby maybe are a little bit, where we have special interests. So some of the things we look for on these images are like crop marks. So crop marks are where crops were likely to have been grown, and therefore probably was a human settlement, some soil discolorations, unusual alignments in the landscape, and so on. And this is a really good method or sustainable method that allows non-invasive ways of preserving heritage without having to excavate them, and also allows us to expand our understanding of ancient cultures. So I'm going to share a publication here, which I authored, which I was the first author from. And here we were mapping archaeological changes that are happening to archaeological heritage. So these points that you see here in white, these are hand-dug wells that are critical for the populations living there in terms of allowing them to have a continuous supply of water despite the dry areas in which they live. So this line here, this black line here, is the border between northern Kenya and southern Ethiopia at a place called Moyale, okay? And these areas have, the populations living in those areas have the same livelihood because the agroclimatic, the climate of that area is the same, the type of land is the same, so they do have dry areas. Majority of the people there are pastoralists, and so we looked at, we did an analysis across the border because of the similar kind of landscapes, and analyzed, the land use land coverage
Oh, can you hear me?
Yeah, I can hear you.
Yes, we
I
can
think
hear
we
you.
lost Pamela for a moment, so let's just hope that the network comes by a bit so that she can join us. Please, if you have questions, you could just use the chat box, or there's a special function called Q&A where you can just submit your questions to, and they'll be answered right after the talk.
Hello, everyone. When we attend these webinars, we give free memberships to 2 students. So we would like to see the students who will put in their names first in the chat. Please, when you put in your name in the chat and your email address, you, as fast as possible, you can have a membership to join this incredible society. Let's go. Great, Benjamin.
Apologies, I had
And
out.
Okay,
Can you hear
Pamela
me?
is back. We have got our 2 people that we are giving memberships to. We have Benjamin and James.
I'll say James, because Kawas
Yeah,
did not put in his email
exactly.
fast.
Please, Ari, these are the 2 people who give memberships to. Please take it
Okay.
over. Thank you.
Okay. Go ahead, Pamela. Yes, you have the floor.
Sorry about that. That was a blackout. Luckily, it just went for 1 second, but it disconnected my Wi-Fi. You can hear me?
Yes, we can.
Okay.
Yes,
Okay.
we can.
Okay, I'm almost at the tail end. So this was showing the changes that were occurring around these wells, and therefore informs, what can we do to mitigate the encroachment of these hand dug wells that are very important for those who live in those places. So this is essentially for monitoring of threats. So just like we can find sites in archaeological sites, we can also monitor threats to them, like urban expansion, like coastal erosion, like agriculture, And so this is our work on that, and this was published in 2022. And then also another example is also, mapping threats to heritage. So this is a most recent publication that just came out a few weeks ago. And again, I'm the first author of this one. And this is, looking at shoreline changes that are occurring and which may affect archaeological sites in 3 countries, that is Kenya, Tanzania, and Senegal. That is countries that have shorelines. And we use satellite imagery to track how coastlines have changed over time from 1984, and what this means for heritage sites in terms of accretion of the coastline or retreat of the coastline, because both conditions affect these cultural heritage sites. Okay, so you can see again, this is social sciences in terms of these cultural heritage sites, but we're using remote sensing to track and analyze, the threats that are occurring to them and how can we then preserve them. And this has been published in the Journal of Maps, the most recent edition of the Journal of Maps. So this work supports more climate resilient strategies that affect cultural heritage sites. So remember, it is climate data, yes, or climate science, but how it affects cultural heritage management and cultural heritage sites. And so just finally, I just want to talk about, so these are just but a few examples, because again, I didn't want to talk for too long. These are just a few examples of how our work has, or how my work has been used in social sciences and how it continues to be used in social sciences. So when you're presenting geospatial data, how do you ensure that your audience is going to benefit from it? So whether your map is going into a report or your map is being shown in a community meeting, it is important that the map is clear and it tells a story. So always ask yourself, what do I want to show? Who is my audience? What decisions will this map support? So with these questions in mind, always design your maps like you're telling a story, because in many ways, you are actually telling a story, okay? So with these slides, I just want to thank you for listening to me. Thank you so much for your time and attention. So I'm happy to answer any questions or share any resources, especially if you'd like to explore some of these tools by yourself. So thank you very much.
Thank you very much, Pamela. Thank you very much. It's been an interesting ride for the past few minutes. So we have a few questions in the chat box. The first question is from Yan. Oh, I'm not going to pronounce the question, the name wrongly, but it's Nyambura Gachahi. He or she says, is climate science considered a social science? Will you take
Okay,
that,
thank you
or do you want me to? Okay, yeah, go ahead.
Yes, thank you very much. So Nyambura, just as I explained in our last slide, climate science is not social science, okay? But climate science can be applied to social sciences, because the models, the tools that are used in climate science are very, what can I call them? They're very technical, they're very technological. But these tools can now be applied to social sciences, because climate is affecting human beings, okay? And so therefore, how you present it, how you carry out the analysis, and for the purpose. So the main thing is, what are your objectives? So climate science on its own, say for instance, developing climate models, that is not social science. But developing climate models and then applying them to communities, okay, to help them, for instance, be able to know when their crops are going to be ready for harvest, or whether they should plant or not, or which areas are more suitable for them for certain activities, it now becomes a social sciences, okay?
Okay, thank you very much, Dr. Pamela. I think the next question by Mary has been answered. This is, how do you get data and what toolbox do you use? I guess that has been answered well enough. So I'll go to the next question, which says, is navigation systems in cars an example of ODK?
Thank you very much. So navigation systems in cars are not really ODK, because it is purely a GPS interface, okay? So ODK, Open Data Kit, essentially allows you to create questionnaires, which from the traditional paper questionnaires, now you're able to create them in a digital format and then upload them into a phone or into a tablet that you can move around with. But with the navigation systems in vehicles, you essentially have maps that, so it's like a Google Maps, just that the same Google Maps that you have in your phone, you have uploaded it into a navigation system in the vehicle. So this is different. ODK allows you to create questionnaires, unlike the navigation system, which is a Google Map that has been uploaded onto the system in the vehicle. Yeah.
While we're still on the subject of ODK, maybe I should chip in this question. Is this ODK the same as the ArcGIS Survey 123? Because I assume that uses internet and this doesn't. Are there similarities, or what can you say about them? Do you know the Survey 123 from ArcGIS or Esri?
I've heard about Survey 123. I've not used it though. I tend to use a lot of open source platforms.
Which
Although
is
in
good.
my earlier years, I used to use ArcGIS because when I was working at ILRI, they could afford to pay for ArcGIS. It was very expensive. But now lately, in my later years, I'm using open source, so I cannot really give a very unbiased comment about the comparison. But ODK and Kobo Collect are both open source platforms and are free. And yeah, but I cannot really comment on ArcGIS 123 or Survey 123. Yeah.
Okay, thank you very much. Still on the issue of ODKs, somebody says, Wajat Rao says, how accurate are ODK apps compared to handheld GPSs?
Thank you very much for that question. So in the surveys, in there's one ODK form that I'm developing right now that we are going to use in Sudan. And it's
Okay.
very specific to Sudan. So one of the things that we are looking at is, so it's just, anyway, that's maybe not so necessary, but I'm developing a form on Kobo Collect ODK that we're going to use in Sudan. And one of the questions that we are asking is, in ODK, you're able to collect coordinates as well. Usually ODK coordinates will go up to 5 meters or even slightly below 5 meters. So one of the constraints that I've put in is that it should not be above 5 meters. And if the highest if the highest accuracy you're getting is maybe 6 meters, it does not allow you, because of the constraints I've put in the system, it doesn't allow you to collect. And then it tells you use a handheld GPS instead. So now that handheld GPS allows you to go below up to 3 meters accuracy. So usually comparing the two, the handheld GPS has better accuracy, up to 3 meters. But even with the ODK, sometimes on clear days, you're able to get to 3 meters. But it's not as common as with a handheld GPS. Yeah.
Okay. So next question is by Benjamin, and he says, in what ways can geospatial engineering help analyze and predict human migration patterns? And how might social science interpret these findings to shape policy?
Can I see that?
Should I take that again?
Yes, please.
In what ways can geospatial engineering help analyze and predict human migration patterns? And how might social science interpret these findings to shape policy?
Okay, thank you for that. Now I understand it. So in terms of migration patterns, the most common analytical tool used is time series analysis. Okay, and time series analysis will be looking at where in what direction is the growth occurring. Okay, do we have more urbanization occurring in a certain place and from a certain place? And this is by mapping, say for instance, 40 years ago, at certain intervals. Let's say you can decide on 10-year intervals to look at how have migration patterns grown. What is the urban sprawl like? Okay, so in this way, you can use geospatial engineering to track migration patterns. And then, using this kind of data, you can then make recommendations for policy in terms of how to bring in amenities, or how to ensure that these populations that are migrating are serviced in terms of houses availability, in terms of water services availability, in terms of infrastructure, and so on. So geospatial engineering is a very strong area for time series analysis that can be used for tracking migration, for tracking urban sprawl, and for tracking any kind of growth that then assists the social sciences to come up with policies that can enable this migration to either be curbed or for services to be provided. Yes.
Okay, so the next question, I don't know if that has answered the question, Benjamin. If it has, maybe you should just say give a comment in the comment section. So the next question says, which drones model do you recommend that can be used for several hours in rural areas for survey?
In terms
Which
of
drone
models,
model? Yeah.
In terms of models, I would have to. Oh, thank you, Benjamin, for confirming that the question has been answered properly. Drone models, I would have to recommend my colleague who is more specialized in terms of different types of drone models, a licensed pilot, and so on, because we work together in a team. And so I think there's a lot of variety out there in terms of, which models, which sensor types you want to use, what is the purpose. So you just need to know what is your objective, and then you can decide on the type of model, the type of sensor that you want to upload, and so on and so forth. Yeah.
Thank you very much. I think we also have more questions in the comment section. One by Svana. It says, in your experience with GIS-based approaches, have you seen any recent advancements where deep learning techniques, especially CNNs or object detection models, are applied to analyze satellite imagery for heritage applications? If yes, could you share any insights or examples?
Absolutely, absolutely. This is something that we are even working on right now. So thank you for that question, Savannah. So deep learning now is the buzzword. It is the newest application in terms of remote sensing applications for classification, for object detection, and so on. So one of the major objectives that we have in our project that we're currently working on with Heritage is object detection. So how can we detect, for instance, we have some common features. Like if you look at this background here that I have, the slide that I have, this is one of the areas that I'm prospecting to find potential archaeological sites. So these round features you see here, these are enclosures, cattle enclosures. Some of them are modern, some of them are ancient. And the way that we can find out that is by also using the time slider to go back in time and see, have they been moving regularly across the landscape? And in this way, we know then that these are modern enclosures. But if they've not been moving, then we know that they are ancient. And object detection is one of the major, applications that we have to kind of detect some of these features. And one of the ones that I have been looking at is following a paper by one of the colleagues that I can share after this, that was using, CNN methods to detect these archaeological sites. And it's worked well, but of course it does have some, false positives, false negatives. And sometimes we've asked ourselves this question in terms of cost benefit analysis. A CNN or a deep learning model takes a long time to populate in terms of labeling the features and so on. So looking at the time taken to develop this system vis-a-vis manual finding of these sites on high resolution platforms like the digital globes, which is it more beneficial to develop the CNN, or is it more beneficial to use the manual method? So these have been some of the issues that we faced, but yes, there's several examples, including one that I'm working on that I can share to you, Swarna. Thank you.
Okay, thank you very much, Dr. Pamela. Very quickly, to answer Hazan's question about how to get membership, I already resent the link on more information on how to get benefit of GRSS memberships also. So I think our final question here would be by also Savannah. Did I get that right? Could you share details about the image data sets used in your GIS-based studies? Were they open source satellite data sets, or did you use custom collected imagery? Maybe I should go to the next question, the last question, so that we don't answer any more questions. The last question is by Monica, which she says, are there any MSc programs where you would suggest if one wants to specialize in spatial science for social good? Yes, so.
All right.
What questions?
Okay, thank you. Thank you. Let me answer. So I'll start with Swarna's. Again, a very good question. So the image data sets that I use in my GIS-based studies are mostly open source. Most of these projects, when you're writing your proposal, one of the selling points is that you're going to use open source, freely available open source software. I mean, data sets, for example. So software, data sets, and so on. For example, I use Landsat, and Landsat, is the largest archive. Oldest, it goes up to 1972. Open source, full coverage of the globe. Sentinel now from a more recent time, from 2015. And then for PlanetScope, we tend to use the, because we are a university, we tend to use the education the education package, which is also free, but the limited quota of 5,000 kilometers squared per month. In only one instance did I use a custom collected imagery, but this was for during my PhD, and there was a project that was well funded, and so we used QuickBird, which was high resolution plus hyperspectral sensor mounted on an aeroplane to collect flower information in 2 seasons. So in only those instances, but in all my other research, I'm always using open source satellite data sets like Landsat, like Sentinel, like PlanetScope, the education package. And then in terms of MSc programs, so what I see in terms of MSc is you can go for any spatial science MSc. For instance, ITC offers, spatial science, that's ITC in the Netherlands, and any other university that is offering a master's in spatial science. And then your specialization in terms of the project or the thesis topic that you choose could be on the social good path, okay? So your thesis, you're free to select, to select the application that you're interested in. So don't limit yourself to looking for an MSc that is specializing in spatial science for social good. Most of them will be spatial science. And then when it comes to your thesis, now you can select a social science aspect. Yeah, that's what I can tell you.
Okay, thank you very much, Dr. Pamela. I think we've come to the end of the question and answer session. Or did I miss out any question? If I did, please let me know. I don't intend to avoid or okay, so I think that's all. Okay, there's another one, please.
The papers. So I'm going to share
the papers and the PDF.
Yeah, as I share the PDF, I'm also going to share the list. Let me just write it down there. So paper on CNN, and then yeah, I can do that for heritage studies. So I can share that together with a list of our papers so that the participants can have a look at those. Yeah.
I think what would happen is you can share with me, Dr. Pamela, and so we can also include it in the recording, also as a link to your PDFs to download or to view, as well as the papers that could be read by the participants.
All right.
Okay.
I'll do that.
Thank you. Yes, thank you very much, Dr. Pamela. I think right now I'll hand over to Mary. Mary has something to say.
Thank you very much, Dr. Pamela. It is really interesting to see how remote sensing goes with social sciences. It's really nice. It was a great presentation. Thank you for your time. Thank you for being here, every participant. We want to use this platform to announce that we in Africa, we are doing the webinar series for Africans by Africans. We are encouraging you all to, to look up for our webinar series, attend them, encourage your friends to attend. There are always surprising packages that we'll bring along when we come for this webinar series. Thank you so much and have a great evening. Ari?
Yes, thank you, Mary. I don't know if Musmi is still on the call and if she would like to say one or two things.
Yeah, thanks, Ari, and thanks, Dr. Pamela, for being the speaker of this first webinar series. This is a very special webinar series started by Mary. This was the brainchild from Mary's side, and this is the first webinar. Sometimes we get delayed due to in search of very good speakers, and I'm glad after listening to you. I'm really glad that you are being part of our IEEE Entrepreneurship Summit as well. I really hope the panel discussion will also go very nice and very insightful sessions and insightful questions will be coming up. Thank you so much, and thank you so much, Eri, for taking the lead for this. Mary, Sunny, Harry, and everyone. I hope we'll be continuing this webinar to encourage more volunteers from Africa side, and we really look forward to uh, give a wide spread of GRSS and a good awareness of GRSS in Africa so that we all can grow together without any discrimination or without we'll walk hand in hand. That is our main purpose of women in Africa growing all together. Thank you so much.
Yes, thank you so much, Muzmi. Just very quickly, someone says this is his or our first time of actually attending this webinar series. So yes, welcome, welcome, welcome. And we have more to come. So I think just so that you be kept in the loop, you should try and keep your eyes on the IEEE webinar series or any events that occurs during IEEE, and you will definitely be informed on our upcoming webinars. And if you want direct information about webinars, you can always write to Mary or Muzmi or myself. And we can also add, because we are growing the Women in Africa and basically African participant team. So if you will be interested in further volunteering work, or even if you'd be interested to speak, or you have someone in mind who you think would be a very great keynote speaker, just like Dr. Pamela, yeah, you can write to either one of us, and that would be great. Yeah. So I think we've come to the end of the webinar today. Also, thanks to those working back end. I will mention names, the panelists, and to Sunny. And yeah, I wish you a very good evening.